This time on Catalyst. Underwater, under ice, and on one of Jupiter's moons. Why is NASA going back for a second look to see if this icy world could have the right conditions to support life?
Underneath that ice, a handful of miles down, is a liquid, warm water ocean. And there might be life in that ocean. And so NASA is sending the Europa Clipper to investigate.
And from cold to too hot, cities are becoming islands of heat every summer. We'll show you the work to find solutions on the ground and from up in space.
It's hotter and hotter every year. It's not cooling off at night.
We need science to understand not just that it is warmer in cities, but why it is warmer in cities. Because only by understanding why it is warmer can we actually do anything about it.
Plus, what kind of mission can connect a planetary geophysicist with a paleoanthropologist? It's all in a name, and soon it'll go into space.
I'd never thought of the connection between space and Lucy herself.
And this space researcher would like to get you and your kids walking on Mars. But please take your shoes off first. Big maps and even bigger plans. We may soon see this project spread out on the National Mall in Washington.
So we help people come away from the map knowing some basics about Mars. Most people know nothing about Mars other than it's red and there's a couple rovers on it. So we want to teach them some of the place names, teach them all the big features that the rovers have explored, and let them know where we might be sending missions next.
That's coming up next on Catalyst. This YouTube edition of Catalyst is brought to you by Arizona PBS and Arizona State University. Life has problems. Science turns them into questions that can lead to solutions and even innovations. This is Catalyst, shaping the future through science research at Arizona State University. In most places here on Earth, when winter comes, plants die or go dormant. Most places away from the Earth's equator get snow and ice. And we tend to think that until things warm up and spring melts that ice, everything is dead. Scientists will tell you that's not really true, of course. Some organisms can and do live underneath ice, especially if there's water under that ice. Earth may not be the only world with water under ice. The Galileo mission zipped around Jupiter back in the 1990s, and it took a look at one of Jupiter's moons called Europa.
And my job was to help plan the observations and to process the images that were returned of Jupiter's 4 planet-sized moons, what we call the Galilean satellites. And these are the satellites here, the moons that Galileo discovered when he first pointed his telescope at Jupiter back in 1610. Here's a view of Europa here made into a small globe. When you study the surface, you're able to see variations in the surface. You see the areas that are darker here that have been more influenced by the emplacement of these salty materials coming up from the interior, from the ocean.
The surface is frozen ice, water ice. Underneath that ice, a handful of miles down, is a liquid, warm water ocean.
You see blocks which look like a floating ice. We see the cracks which are colored. We see salts in those cracks. If ocean is salty, we would expect salts in those cracks.
So imagine the Mercury-sized moon Ganymede orbiting Jupiter, and it causes sort of an eccentricity in the orbits of the inner 2 moons, Io and Europa. And that eccentricity is sort of a gravitational tug-of-war between Jupiter and Ganymede, causes the crust of these 2 moons to flex up and down. In the case of Europa, it flexes up and down about 30 meters every 3.55 Earth days.
That flexing could generate friction. Friction could create heat, energy. And if you've got water and energy and the right chemistry, you might have what is needed to sustain life.
And there might be life in that ocean. And so NASA is sending the Europa Clipper to Europa to investigate and learn more about it, try to figure out if there's an ocean and how deep it is.
So there is a bit of variation through the surface, and one of the goals of the Europa Clipper mission is to understand how thick is the crust in different parts of the globe, and where might the crust be the thinnest, where it's easiest for the ocean to communicate with the surface.
We're building an infrared camera for that mission. It's going to launch in 2020. Our job is to measure the temperature of the surface. Again, it's extremely cold, but if there's warm water near the surface, then that's going to warm up the ice, and we'll see that in these infrared temperature measurements. So we're essentially building, a night vision goggle camera that will look for warm spots on Europa. The reason that's interesting, we want to get eventually into the ocean. And if you're going to melt through miles of ice, you want to find the place where the ice is the thinnest, and where the ocean is the closest, it'll be the warmest. So we'll say, hey, there's some warm regions down here, that's where we should land, that's where we should eventually drill to try to get into that ocean. So, finding life on another object would be really stunningly exciting.
If you live in southern or central Arizona, chances are you come here up north in the summertime. Flagstaff is high, 7,000 feet, and it's cool here, summer or winter. Now, every summer, Flagstaff still does something that many larger cities around the globe struggle to do. It cools off at night. Now, many big cities are becoming what scientists call urban heat islands, places where the heat that builds up all day persists. So both days and nights are getting and staying hotter. Now, we feel it down here, but the best place to see and solve the problem may be from up there in space.
I'm a Phoenix native, and it never used to be this hot when I was growing up. It's hotter and hotter every year. It's not cooling off at night.
And if you can't cool off at night, then the next day is going to be much worse.
And what we've seen in Phoenix is that over the past 50 years or so, the nighttime minima have slowly crept up about 8 degrees Fahrenheit over that period of time.
Sometimes the low is 80 or 90 degrees in the summertime. That's extraordinary, and it's new for the city of Phoenix. It wasn't like that in the 70s or the 80s.
Here's what is happening. Summer sun shines on the concrete, asphalt, bricks, steel, and other materials we use to build our cities.
The urban heat island manifests in the city core, particularly where we have urban materials that retain the heat.
All those materials soak up and hold on to that heat.
So we're going to measure the surface temperature of this fairly cured asphalt here. So 108.5 degrees.
So this is a nice direct comparison of how hot surfaces can be if they're dark versus light, illustrating how hot dark surfaces can be. Now the light surfaces here are just traditional roads. You can imagine that these could be even lighter, but if you look in the infrared image, what you see is a very clear distinction between the warm old asphalt and the very hot fresh asphalt. And that is just indicative of the role that surface reflectivity can play in surface temperatures, and that of course has a connection with air temperatures.
The air temperature is built by a variety of different factors. One of them, the main component, is the surface temperature. So different surfaces are going to respond and heat up differently.
As these surfaces heat up during the daytime, they get warm and they cool off at different rates at night. In urban settings, there tends to be a lot more complex topography, and so surfaces that get hot during the day cannot radiate that energy to space as efficiently at night. They tend to stay a little bit warmer, whereas if you're out in the open desert, for example, those surfaces are radiating to the night sky, and they actually can cool off even below the ambient air temperature at night.
So, nighttime temperatures never get as low as they should. And as the sun rises the next day, the city has a head start on another hot day.
Edison East Lake is a particularly warm part of the city.
People in lower-income neighborhoods often suffer the most from the heat island effect.
It's also in a poorer neighborhood, so there's less adaptive capacity of the populations to deal with extreme heat.
This is one of the major hot spots in the city. It's over 130 degrees in the vacant lots during the summertime, and there are a lot of vacant lots in this neighborhood.
Their homes may have older, weaker cooling systems, or none at all.
We have senior housing, a lot of seniors in this area that can't take that 86, 87 degrees that's as cool as we can get it when it's 115 during the daytime and 90 at night.
So when you're overheated and you become dehydrated, that's one of the first signs, absolutely. But if you've gone past that, or if you're ill, or if you have other situations that make you a little bit more susceptible, then you can present in the emergency room and easily go into a coma and die. On average, it's around 118 that die annually. And that, in my opinion, is too many, but it is a state statistic, and sometimes it changes. And it is dependent upon weather conditions as well. So when we have weather conditions that are particularly oppressive, then we'll see higher incidences of heat-related illnesses.
In Edison Eastlake, the city initiated a planning process and also worked with ASU researchers to help explore different strategies for how to develop the neighborhood differently.
So vehicle ownership was less than 30% of all the residents, which means they're all taking the bus. That's a big deal in the summertime. When it's 115 degrees and you have to walk to the bus, and that's the only transportation you have to get to work.
In the early days of heat mitigation, there was this effort to just plant lots of trees, and it became apparent relatively quickly that you need to have several concerns in mind when you pick the tree species. We can actually create entire lists of tree species that have the best combination of drought tolerance and limited emissions of organic compounds. One of the strategies is highly reflective materials, but that strategy would typically be limited to flat rooftops because there's just too much of a glare issue when you have a white roof on a sloped roof. Now there are engineered coatings that are very highly reflective to the energy content of the sun outside of the visible spectrum, but might look tan or gray to your eyes.
ASU research is taking aim at the heat island on the ground, and soon it will also be looking at it from above, from a satellite in space.
The Phoenix CubeSat mission is a satellite being built entirely by undergraduate students here at ASU, and its mission is to take thermal images of the planet, cities across our planet, to study the urban heat island phenomena. My name is Jaime Sanchez de la Vega. I'm an aerospace engineering student here at ASU, and for the Phoenix mission, I'm the chief engineer and the mechanical engineering lead. We got together and with the help of a professor here at ASU, Judd Bowman, we wrote a proposal, sent it to NASA. It got accepted, and now we're building a satellite for NASA. Most satellites are the size of a school bus or a large fridge, but this one is like a loaf of bread you can actually hold. Here is a thermal camera. This has been my FLIR. It's a thermal imaging camera that will be taking pictures of cities. So say we're flying in space and we see, okay, this is the city of Phoenix right here. When we see it, we can point at it and take pictures as we fly by. The center part of the city will be a bright yellow, and that means it's supposed to be hot. And the environment, the surrounding of the city and bodies of water will be some purple or some darker color, and that means it's cold. So you will be able to see with your eyes that there's a very significant temperature difference. That is the urban heat island, and that's what we will seek to explore with this mission.
Part of what we seek to do is to find ways in which we can actually reduce the exposure of the most at-risk populations to extreme heat.
So this weather station is collecting a variety of atmospheric data here in central Phoenix. So all these instruments collectively are giving us an idea of what the atmosphere is in this part of the city. So using all of those things together, we can see what the baseline is from this, and then as we change the neighborhood, what are those effects for the person walking through or living in the neighborhood.
Arizona State University is involved in better understanding the heat island problem and in finding solutions.
And a member of the ASU Heat Ready team will be a member of that design team, and will have input and ideas for us on how design can mitigate heat.
We now have a much better sense of the magnitude of impact they can have through those measures, and at the same time we have a much better understanding of how we can engineer better materials for the urban environment. The city has limited resources, and so the question of whether to fill a pothole or to plant 100 trees, that is a tension for limited resources. So anytime you have limited resources, there's a question of where should the city best deploy them.
If we keep letting it get hotter, who's going to want to live here? And who's going to want to move here?
So what's the temperature of the water, say up there? Say that number? 64.6. They came in here from my car. They were both 64 degrees. Both the sand and the water were 64 degrees. And what's your temperature, say right there?
When I talk about climate science, climate change, I try to bring in ideas of the physical system.
Teaching young minds about how heat islands happen.
They're what, 10 degrees different? This is 10 degrees hotter than this?
Some of these high schoolers may go on to study and solve the heat island problem.
Absolutely, this is a tool, the infrared thermometers. So can we use the technology to help us predict which is going to be hotter and which is colder, and then to measure it?
I tend to move away from advocation and talking about specific policies, and instead allow those students to make their decisions once they understand their impact in the climate system.
We need science to understand not just that it is warmer in cities, but why it is warmer in cities. Because only by understanding why it is warmer can we actually do anything about it.
Ethiopia, 1974. Paleoanthropologists Tom Gray and Donald Johanson discovered this skeleton. It's tested and proves to be more than 3 million years old. It's a hominid, not a human, but possibly one of our earliest ancestors. It's female. They name her Lucy. It's now regarded as the most important fossil hominid ever found. You probably can't top a game-changing discovery like that. But if you're Donald Johanson, well, check your email.
Growing up in Connecticut, one of my hobbies in high school was astronomy. I was sort of president of the astronomy club at my high school, and I bought a telescope, and I'd go out and look at the moon and draw the craters and so on. So I always, that is the universe, right? I mean, it's an incredibly exciting place. And Lucy was named after the Beatles song, Lucy in the Sky with Diamonds. And recently, a few years ago, I received an email from a NASA researcher. And the email opened by, "This may be the strangest email you've ever received." And Hal Levison is a researcher for NASA, and he has proposed a mission which will take place in 2021, and ASU is very involved with NASA, as you know, and a lot of scholars here are working on this project with NASA. And the project is called the Lucy Mission, and it is a rocket that will be sent to study the asteroids, the Trojan asteroids between Jupiter and Mars. And those asteroids, astronomers have always thought, are the remnants of when the solar system was created, the things that didn't accrete, didn't collect enough to make a planet, but they're out there floating around.
The gravity of Jupiter, the gravity of the Sun has captured a cluster of asteroids. Some are moving in front of Jupiter, some move behind Jupiter, but they've been captured there billions of years ago. And these might very well be primitive, frozen relics of the first few million years of the solar system. They might be covered with ice, they might be covered with organic material.
And we may gain some real insight into how our solar system originated. This expedition is said, and is hopeful, that the Lucy mission will tell us as much about how our solar system was created as Lucy did about how humans originated.
These Trojan asteroids, they truly might be pristine relics of how the solar system formed. So Lucy is going to fly by 6 of those over a 10-year mission and just look at them up close and see what they look like, what they're made of. We are, again, building an infrared spectrometer. We'll try to measure the spectrum. We'll also measure the temperature of these objects, and from that we'll learn about the physical properties.
And it's a mission that goes out in 2021. I was incredibly honored when this email came, and I'd never thought of the connection between space and Lucy herself. And I feel very honored about it. I'm very excited that it's happening on our campus with many of our people who are connected with NASA. And I look forward to that launch in 2021, which is going to be down at Cape Canaveral, and you can bet I'll be there.
This is NASA's Odyssey spacecraft. It has been orbiting Mars for almost 18 years. During that time, it's made over 73,000 orbits and taken over 230,000 infrared images of the Martian surface. These images help scientists better understand the topography of the red planet. The pictures may one day serve as a map for the first humans on Mars. Human travel to Mars won't be possible for at least another couple of years, but some of the first steps on the Martian surface may have already been taking place in a high school gymnasium.
So the big idea of Walk on Mars is to give people a physical experience of the Martian surface, so that it's not just an imaginary place to them, but a real physical place that they feel like they can visit.
These are thermal images of the Martian surface from Odyssey's THEMIS, or Thermal Emission Imaging System. Jonathan Hill and his team use these images to create these maps. But Hill's maps are not like the ones you would find on a classroom wall. His can fill a gymnasium. This one is over 47 feet wide and 95 feet long, just about the size of a basketball court. And that's small in comparison to what they hope to do next.
The map was created using over 24,000 images taken by ASU's THEMIS camera, which were then digitally stitched together into a single image. And so it's very similar to a rectangular map you would see of the Earth. You see all of the surface, but towards the poles it gets a little stretched out. So our original map, which is only the size of a basketball court, has already done 22 events across the Southwest in 4 different states. The map is printed by a company called Cuban Nicholson. They're a large, very large format printer, and they had previously worked with the National Geographic Society on printing these sort of library-sized maps of the states. And so kids could walk across and actually explore their own state in more detail. I contacted National Geographic. They referred me to the company, and luckily they had no problems printing something that large. Our end goal is to have the map printed at full scale, which would take up the size of a football field. And we would like to do sort of stadium-sized experiences where people can come in, walk around, see the full resolution of our map, and really just sort of get familiar with Mars as a place. So getting to that point is a little difficult. Logistically, the map pieces are very, very heavy. We'd end up with about 2 tons worth of maps. But then funding-wise, we need about $35,000. We're working up towards that goal slowly but surely, but any help is appreciated.
And the Walk on Mars program is not just for kids.
So the United States' Mars exploration program is really a national program. There are people in every state, pretty much every university in the country involved in some way. And so we want to kind of bring that back to the people that have paid for it, the taxpayers. You know, they've allowed us to do this great work, and we want to share with them in a sort of unique way what we've learned about Mars and what we're going to try to learn next. So we help people come away from the map knowing some basics about Mars. Most people know nothing about Mars other than it's red and there's a couple rovers on it. So we want to teach them some of the place names, teach them all the big features that the rovers have explored, and let them know where we might be sending missions next.
Walk on Mars's next mission will be Washington, D.C. This fall, the giant map of the red planet will be displayed at the National Mall. The goal is to get more kids interested in space exploration, one small step at a time.
You see it connect with a lot of kids. You know, they come in, they're just having fun at school, and they walk on the map, and you can just see in their eyes that just opening up that this is an entirely different place that they can go to and explore. So I think that's very possible that the people walking on the map now might be walking on Mars for real in the future.
Thank you for watching Catalyst. I'm Professor Vanessa Ruiz. And because science always has new questions to answer, we'll be back soon with more stories.
Catalyst is supported by Knowledge Enterprise Development at Arizona State University, advancing entrepreneurship, innovation, discovery, and knowledge for the public good.
Subscribe to this channel to see more episodes.